Hey friends, so today we are going to learn a topic that how we can scale our database. So it's a system design topic. So let's get started. So as we know that let's say there is a app which have a database. Okay. Now let's say the app have only 100 users. So a normal database can be will be can handle all the requests. But let's say the number of traffic is getting increased. Now the app having let's say 1 lakh users. So 1 lakh or 1000 or 1 crore, or let's say the number of users are getting increased continuously. So now the database that we have cannot handle all the requests out, right? So what will happen, there will be more load on our database. Load will be increased as the traffic is going to increase. So what it will do, it will ultimately slow down our app. So we should properly scale our database so that we can ensure that performance of our app does not have an impact. So here we are going to discuss what are the strategies we need to follow in by which we can scale our database. So the first strategy is vertical scaling. What does this mean? Vertical scaling, you can think like this. There is a database. Let's say this is our current database. Okay. This is our current database. I am saying this is as our DB. What we will do, we will purchase a machine which is of more there where it can have more RAM. Okay, it can have more CPU. Okay, and it can have more storage. So this is the simple thing that we can do a large DB. Okay, we can purchase a machine which is more powerful than the current one. So this is the one of the solution, but again it has some limitations because we can't go after a certain extent. So there is a limitation on this. And one more thing, that let's say our DB is crashed. So if we have only single DB, which is a very big DB, so I would say that it would be a single point of failure. Okay, so if there is a single point of failure, so it doesn't sound good, because once this something happen, something miss happened, so our all the data will be gone and our app will be down. Or okay, so we you can consider like this, that we can't put all the eggs in a single basket. So yeah, vertical scaling is a good approach. If let's say there is a scenario that there is a sale on Monday. Okay, so you know that on Monday there will be a huge traffic. So for that particular day you can add or you can increase the size of that machine. Okay, like this you can go for it. Let us discuss the second approach, that will be indexing. Okay, so what does indexing means? So I will help you to understand this by a simple example. Let's say we have an entire book, right? Now if you want to search for a topic, what you will do, one thing is that you go each page and check whether that topic is present or not, correct? Or what you can do, in the start of the book there can be an index which have all the list of the topics. Okay, all the topics are present. So now it will be very easy for you to recognize whether that topic is present or not. Similarly, the indexing work in the database as well. You don't need to go each row to identify whether our required element is present or not. Similarly, a book have indexing, we can also index our database to some columns. So basically here what we have, let's say we have a table, okay, which have column 1, column 2, column 3, column 4, right? Here what we have written, here in the book we have made the titles in the starting. Okay, so let's say here also we have a column title. So what we will do, we can index on any particular column, or we can also index on any two columns. Let's say we have second column as author. Okay, so we can index on the two columns as well. But again there are again some advantages as well as disadvantages for this. What are advantages? Advantages are, if you do indexing, then I think read will be faster. But what are the disadvantages? That if you are going to write something in your database, it will be comparatively slow. Why? Because it is again internally using some B arc tree concepts, which is again a big topic to discuss. But you can say that uh, if we are applying indexing on a particular table, so the reads will be very fast, because as you already know that what are the topics that you already have in the book, so you can directly check and return the value. So this is the second approach in which we can go and scale our database. The third approach that can help us to scale our database is sharding. So what does sharding means? Let's say we have a big machine, okay, which have currently, let's say, 3 million rows, right? Now let's say all the users are accessing the same database. Okay, so what will happen, as there is a single machine and which is holding a very large amount of data, it can run out of space, or it can slow down when the people are started using it more. So what we have to do is, there is a big machine, right? What we can do, we can break this big machine into smaller machines. Let's say we will have now 3 dbs, each db have 1 million rows. Okay, like this, what we can do, we can shard our database to some smaller databases. Now again, sharding can be happen on multiple factors, right? Let's say we have a directory from A to Z. So what you can do, you can dump the data from A to K here, then K to P here, and P to Z here. So there are some different ways of doing sharding, which is again a very big topic. But again, let's say if you shard like this, then you will get to know, okay, now where I need to search in db1, because let's say you want to search for a letter, let's say which start with B. So you have the idea that you should access the db1. Okay, like this you can shard the things, so that there will be no single database, the database will be smaller databases, right? So like this we can do it. The next approach that we have is vertical partitioning. Now what does vertical partitioning means? Okay, so let's say there are some columns which are accessed more frequently than the others. So let's say there is a table, okay, which have so many columns. Let's say column 1, column 2, column 3, column 4, column 5. But let's only these 3 columns are getting used a lot of time. These columns are required, but they are not required that much. So what you can do is, you divide this single table into multiple tables. Okay, so let's say these are 2 tables now. Okay, this will be table 1 and table 2. It have column 1, column 2, column 3. This is column 4, column 5. Now what we have done is, we have divided our table into 2 tables. Now as there are the amount of data is less, so now our performance will be increased. Okay, because we have reduced our database, so queries will take less amount of time and the performance is going to be increased. So generally e-commerce application used to do this thing. So they have some core product, okay, they used to maintain db like this. There are some core product, the products which are used very frequently, and there will be some here they have the details like this. Let's say there will be product name, id, price, and category, right? And there will be some details table as well, product detail table, so which will have the details regarding the description, specification. Okay, so what they have done, they have divided their entire data into other database. And they can also have some media table as well, which will have related photos and some videos. Okay, so like this, the e-commerce website used to partition their data so that the queries can be faster. So as of now, we have seen 4 methods which can help us to scale our database. Now let's say let's move to other method, which is known as caching. So what does caching mean now? So in every application there are few things which are used very frequently. So I will give you one example. So let's say you have a team where the report is getting generated every week. So there will be report for first week, second week, third week, fourth week, fifth week. Okay, like this reports are getting generated. Now let's say I'm standing at week 6 and I want to see the data for week 5. Week 5 will be data from Monday to, let's say, Monday to Friday or Monday to Sunday, you can say like this. Okay, now this information is same every time, because it is the data of the last week, and this data is fixed, and the information is constant. So in that case, what we can do is, let's say this is our application, right, and this is our DB. And what we will do here, we have some, let's say, cache memory. So instead of directly hitting to DB, what I will do, first I will go to caching, and if I have the data of week 5, I will ask the cache that, okay, do you have week 5 data? He will say yes, I have, so I will give it. So there is no need to do all the operations again and again. So here the speed will be increased very much. Okay, there are some points where the you are doing some calculation which is taking, let's say, 20 minutes, or let's say 10 minutes, that are happening on the heavy database, and there are so many SQL joins are that are required. So the queries are taking 10 to 20 minutes. But once you got the data, okay, you got the result, what you will do, you will go and store in the cache. Once you store in the cache, now application can directly use the cache, and now you can get the data in the milliseconds. So you can say that from 10 minutes to 10 milliseconds you have improved the performance of your application. So like this we can increase our scale our database. So the next thing that can help us to scale our database is replication. Now what does the replications mean? Replications mean, let's say our database is located in only one region, and there are users that are present from other regions. So what they will face? They will face higher latency. Higher latency means they will face some delay, because they are from the different region. So to access the data, it will be very difficult for them, and it will be very slow for them. So what we will be doing, let's say this is our primary database. Okay, what we will do, we will replicate this database into different regions. This is our database 1, database 2, database 3. What we will do, we will replicate our database into different servers and different locations, so that this the person, let's say, using North America, they will use the database which is present in their region. The person from India will use the database which is present in some, let's say, Mumbai, Kolkata, or somewhere where we put our machines. And the person from, let's say, from other regions will access the database which is near to them. So now as they are as they are getting the data from their nearest database, so it will be very smooth for them, and performance will be increased. Now again, here there will be again so many concept, that how the database is getting how the data is getting coming from this is known as master, and this is known as slave. Okay, how the data will get transferred from our primary DB to secondary DB. Okay, this is again a very big topic of discussion, that data can be copied synchronously, or data should be copied asynchronously. Okay, these are so many topics to discuss, but as of now I will just giving you the idea that you can do the replicas of the DB, and that to the different locations, so it can help us to identify it can help us to improve our performance. The next thing that we are also using in our organizations are the materialized view. So now what is materialized view? So there are some complex queries, okay, which are taking lot of time to execute, and you can't skip that queries. You already have optimized the queries, but still the queries are so big that they are performing lot of joins, they are performing a lot of tables, they are joining lot of things. Now what you can do is, as you already know that queries will take time, this is for sure that they are going to take time. So getting the data at the runtime will be a very bad impression. Okay, so what we can do is, we can pre-compute our calculation, we can execute that query, and we can make a dummy table. Okay, this will be our dummy table. What we will do, we will execute our query, we will get some data, and we will put some data in our dummy table. Now whenever we require that data, what we will do, we will get the data from that dummy table. So this is more of what happens actually when there is a materialized view. So basically materialized view are pre-computed disk stored result set for a complex queries. So here what is going to happen, these are like these are not actual tables, I would say these are virtual tables. Okay, this doesn't exist in real, but yeah, that there they can store our results and they can give us the results very quickly. Okay, so lot of e-commerce website used to do this, and lot of other organization also used to do this. So like this, this is one of the way in which we can optimize our we can scale our database. I think we have discussed a lot of ways. Okay, if I want to add one more way, it will be horizontal scaling. Okay, what does horizontal scaling means? Let's say we have a one database. Now again, horizontal scaling is nothing but in other words, it's again the replica only, that we are creating again the replicas. Okay, so yeah, I think more or less we have discussed all the things. So if I want to summarize what are the topics that we have discussed today. So it will be vertical scaling, and the second topic that we have discussed was indexing. The third topic that we discussed was sharding, and the fourth topic that discussed was partitioning, and the fifth way in which we can do is the caching, and the next approach that helped us was the database replications, that to different reason. If the database is replicated to different reasons, so it will be like, it will also help us in the disaster management. Okay, and the last one that we have discussed was the materialized view. So if we follow these ways, we can scale our database easily. Scale our database. So yeah, I hope everything is clear. Still, if you feel, do you have any doubt, you can discuss with me on the comment section. Thank you.